Welcome to lecture CO2, solid wall construction. With this lecture, I'd like to dig a bit deeper into solid wall structures and how they're in general made. We do them obviously for the purpose to be able to settle and to defend against a climate situation. As a principle, we do this by stapling given material, rocks, on top of each other in the first step as a drywall system and later as a mortar wall system, which we see here in this Roman sample. So rocks stapled on each other, filled with mortar to give them a better position and to get them rain and airtight as a total system. This is a sample of a typical solid wall structure, which we nowadays tend to do with artificial made bricks, various ways of making these bricks, and then having maybe an inner plaster layer to seal the inside, not only for aesthetics but also for airtightness as a system. This is such a sample. Nice building in Leiden, which shows this solid masonry structure with an inner plaster layer. Alternative way of doing is a stick system, timber stick system, done as a main skeleton structure, which we see here, the stick system as a structure, which is then enveloped and closed with this sample clay in the opaque areas and the windows in the areas where we like to have transparency in this system. And the current way of doing this is an inner solid structure. It could be concrete, could be masonry with an insulation layer and then an outer layer of cladding in this sample, again a masonry structure to be used. And here we see how this is done. We see the main concrete structure, we see the insulation layer, and we see the masonry layer being added at the outside to this structure. We have two ways of doing these solid walls, warm and cold facade, as we define them. The system warm facade works in the way that we have an inner solid structure. Then there's an insulation layer, which serves the question of insulation of this main structure, which is then covered with, for example, in this sample, a plaster. This is how it may look like. You see it's an inner solid structure. Obviously, there's some insulation placed, and then the whole thing is plastered to wrap the system. In comparison to the so-called cold facade, cold in that way that we have this cavity here, which allows air to ventilate, and by that the insulation is positioned against the air, by that being positioned against the cold outside, and that's why we define it as a cold facade. We see an inner masonry structure, we see the insulation, we see the cavity for ventilation of the air, we see an outer cladding. Cladding could be done in various ways as we may like for our designs. The sample I show here is we see an inner solid structure, we see the insulation in this area, there's a cavity here, and then there's an outer masonry structure, which is closing the outside and sealing the outside against rain as a system. Next step is to integrate openings into these systems. Openings are integrated in the general way to punch a hole into this solid structure, and the simplest way to do so, to take down the loads from the top, putting them aside and then helping them to find their way down the system, is having a kind of a beam being located here. So this may be a horizontal beam. In the beginning this was done with timber beams, later done with stone beams to be positioned, and then some of the Roman architecture we learned to build arches. This is a typical arch, really following a circle as an arch system, as well as this main picture here where we have a circular arch, which is then followed by the Gothic architecture, creating more a force-following shape, so a parabol-like shape, which follows the forces more and smoothens down the transport of forces. And the current step which we do is having maybe a concrete beam being positioned here, and then having some artificial bricks being positioned, looking like a brick structure. But when we see this, we know there's a typical beam which has to take the loads as a principal set. If the opening is made, we need to have a window. We have three main ways of doing these windows. It's a single glazed window, so one single layer of glass being positioned. Advantage of this, it's simple to be installed. Disadvantage, obviously, we lose a lot of heat, which is why we developed the next level of this type of windows, so-called boxed window. It's actually adding two layers of single glazed windows. And this may look like this. So we have an inner single layered glass window with an outer single layered glass window, and we have to open them. And obviously, you can identify it's going to be complicated to have them both opening to the inside. There's systems doing so, but that may end up in being complicated. So in this sample, somewhere in East Germany, the inner window opens to the inside, the outer window opens to the outside. You also see the inner window is quite large, which means that we have to take care of that in the inner situation. There are situations where these inner windows are supposed to be taken out, stored in summertime, and then replaced in wintertime in these system. Another set how this may look like boxed windows, as we call this in San Sebastian. No, this is in Bilbao. Sorry. We see it's a similar, same set as this one, just that the size is larger. So we see the inner layer here. We see the inner layer here at this part, and then we see the outer layer here. And these two layers create the box. And then depending on the temperature, can be quite cold in Bilbao. You either use this as an energy collector by sun heating up the inner part, or you're opening it in summer to allow a lot of cross ventilation, maximum cross ventilation as possible. This is a traditional box window. We can identify, we can find newer box windows doing the same functionality in modern architecture as well. And if this next level of window has to appear, the insulated glass units, IGUs, are investigated, developed. An IGU actually works with two layers of glass. We have an inner and outer layer. We have a spacer in here, and then this whole set is positioned in a frame system, and to allow to get an openable opportunity for this system. We do have three general types of these window systems. It's either a timber system, which we just saw with some aluminium bars at the outside, a rain reason, we see that later. An aluminium or steel system. This is an aluminium sample with a spacer to prevent the heat losses in this part, or a pure PVC vinyl plastic window with some additional structural support, which we see in this part. We will dig into that in later lectures, but say a general sample of opportunities or U values which we are able to create. U values mainly related to the glass and then also to the frame in a second level as a physical result, so to say. This is the end of this lecture. Again, some literature if you're interested. And again, I'm going to stop it now here.